Hello students, Mr. Brooks here. Welcome to Limits Day 2. First thing you want to remember is what a limit is. So a limit is used to describe the value that a function approaches. There are several techniques that we will be learning today for evaluating limits. The first is something called the quotient theorem. So if you look at the example here, a technique for evaluating that limit is if the limit of f of x, the numerator, and the limit of g of x, the denominator, both exist, and the limit of the denominator does not equal 0, then you can simply take the limit of the numerator divided by the limit of the denominator. In other words, in example 1, you can simply substitute 3 in for x in the numerator and denominator and evaluate. When you simplify it, you end up with 1/4. So the limits as x approaches 3 of rad x plus 1 over x squared minus 1 equals 1/4. The next technique used to evaluate a limit is where the limit of f of x, again, the numerator, and the limit of g of x, the denominator, both equal 0. In that case, that means there is a hole in the graph. So you can try one of the two following techniques. The first is to factor the numerator and denominator and simplify and see what happens. And the second one is if the expression involves a square root, you can try multiplying numerator and denominator by something called the conjugate of that square root expression. Let's look at example 2a. Start off by substituting 1 into x in the expression. 1 plus 2. And you see you end up with 0 over 0. When that is the case, let's try technique A, where we factor and simplify. The numerator is a trinomial, so that can be factored into x plus 3, x minus 1. The denominator is the difference of squares, so that can factor into x plus 1, x minus 1, and again it's the limit as x approaches 1. You see that we can simplify out the x minus 1 expressions, and we are left with the limit as x approaches 1 of x plus 3 over x plus 1. Now we are going to try substituting 1 in for x again, and you see we end up with 4 over 2, which simplifies to 2. So the limit as x approaches 1 of x squared plus 2x minus 3 over x squared minus 1 equals 2. Next technique is where there is a radical in the expression. If you simply substitute 0 in for x, you get 1 minus 1 plus 0. And you end up with 0 over 0, which you cannot have. So we are going to multiply numerator and denominator by the conjugate of the expression where the radical is. And again, the conjugate is you take the numerator and you simply change the sign in between the two expressions. So it goes from subtraction to addition. Whatever you do to the numerator, you must also do to the denominator. When you FOIL out the numerator, you end up with 1 minus 1 plus x. The denominator we aren't going to multiply out, and you'll see why in a moment. So we are going to leave it simply as x times 1 plus rad 1 plus x. When we simplify the numerator, we get negative x over x times 1 plus rad 1 plus x. And you see the negative x over x can simplify into negative 1 over 1 plus rad 1 plus x. And again, this is the limit as x approaches 0. Now what happens when you substitute 0 in for x? You get negative 1/2, which is the limit in this example. The next we end up technique is where the limit of the numerator does not equal 0, but the limit of the denominator does equal 0. When that is the case, there is a vertical asymptote. So either the limit does not exist, or the limit equals positive infinity or negative infinity. Let's take a look at a few examples. Example 3a. If you simply substitute 1 in for x, you get 1 over 0, which you cannot have 0 in the denominator. So what you should do is draw a quick sketch with the help of your calculator. And here's what it looks like. We have a vertical asymptote where x equals 1. One branch of the graph looks like this. The other branch of the graph looks like this. And you see the limit as x approaches 1 from the right side of the graph is positive infinity. So as x approaches 1 from the right side of the graph, we head up towards positive infinity. However, the limit as x approaches 1 from the left side of the graph, we approach negative infinity. So here we are approaching 1 from the left side of the graph, and the branch shoots down towards negative infinity. When the limit coming from one side does not match the limit coming from the other side, we say that the limit as x approaches 1 of 1 over x minus 1 does not exist, since you get a different answer depending on which side of the graph you are coming from. In example 3b, again, if you substitute 1 in for x, you end up with 1 over 0. So, graph a quick Cartesian plane. We have another vertical asymptote where x equals 1. The branches in this problem, however, look slightly different. So what you notice is the limit as x approaches 1 from the right side is positive infinity. And the limit as x approaches 1 from the left side of the graph is also positive infinity. Since the coming from the left matches the answer coming from the right, we say that the limit as x approaches 1 of the entire expression is positive infinity. The final technique is where x is approaching positive or negative infinity. Here it's approaching positive infinity, same one with example 4b. When that happens, there may be a horizontal asymptote. So you need to use your knowledge about horizontal asymptotes to evaluate the limit. In example 4a, the degree of the denominator, which is 4, is greater than the degree of the numerator, which is 3. When that happens, the limit, there is the horizontal asymptote is y equals 0, so that is what we say the limit is. The limit is 0. For example 4b, the degree of the numerator, 4, is greater than the degree of the denominator, 2, in which case there is no horizontal asymptote, and we say the limit is infinity. Thank you for watching this video, and please make sure you do the 7 homework problems on the next page. With